Okay, so we are now live and recording, and appreciate everyone's time up front to complete that pre-test. Want to go ahead and hit that before we really start rolling here with the flow of our workshop today. And again, that link is in the chat for anyone who has not yet completed it. But I want to officially welcome everybody on the line to the IHS Water Loss Program, and this week is our AWWA M36 workshop, where we're going to be diving into the American Water Works Association M36 manual methodology of water auditing and water loss programs. So it's going to be we're going to start with just really the key concepts and working through what's known as the water balance, which is really the anchor of the M36 methodology. We're going to be talking about the tools and resources that are available to us, such as the water audit, the M36 manual, and different resources that we're going to have up on our program website. But then there's going to be a lot of points where we're going to have some good interaction through small groups and just different knowledge comprehension and fun quizzes that will be taken throughout the program as well. But we really want you leaving this workshop with a much better understanding of how to use the AWWA free water audit software, how to apply the M36 methodology, and also working with our team members through these small groups, just knowing that we are a resource throughout the duration of the program to help this continued learning and applied knowledge to really establish your water loss team and your water loss program in your tribal utility. So I want to thank again everybody for taking time out of today and this week. We're going to be spending a lot of time together this week, for being here and your interest and commitment to this program. Before we get started, I do want to open it up to Ty Antonio to give any opening remarks to the tribal utilities on the line and the local IHS staff that are attending as well.
Good morning, everyone. I'd like to thank everyone for joining today, and I hope that you guys can attend the rest of the meeting, not meeting, workshop, sorry. Still trying to adjust to the hour change here in New Mexico. Again, I'd like to thank everyone. And if you haven't received your M36 manual, you can ask Drew. I do believe you had a tracking number for all of them. So you can message Drew. And again, if you have technical difficulties during today or throughout the week, you can message Drew or Will. They have their numbers in the chat. And I'd like to remind folks, the HSC does have other trainings available. We have the trainings available from pumps and motor troubleshooting to asset management. And we do have some EPA webinars are available. And we recently added a new one for cross connection control, which is pretty good. What else I'd like to talk about? I think that's pretty much it. Thanks, folks, and we'll see each other throughout the rest of the week. And do you believe, Sherry, you're on? Do you have anything else you'd like to say?
Thank you, Ty. Nothing really to add. Thank you again for participating in this program. And if you have any questions, please feel free to send Ty or me an email. Thank you.
Great. Thank you, Ty and Sherry, for saying that. Sounds like there is no shortage of great learning opportunities available to you. In addition to the topic that we're going to be covering today on water loss and water auditing. So thanks for those opening remarks, guys. Before I walk us through our agenda, so we first met, most of us on the line first met in January, where we had an introductory session. I know there's a couple new names on the line where you're either filling in or perhaps your representative that attended the January introductory session said, hey, you need to be a part of this program, in which case that's fantastic. But we did a really detailed introductions at that time. So we're not going to go through another detailed round of introductions, but that was a great way to learn more about each of the tribal utilities on the line. We talked about just kind of getting a better understanding of the size of the tribal utilities on the line, the challenges that some folks may have when it comes to water loss control, and also some of the good things that the tribal utilities on the line were doing with respect to water loss control. So we won't go through that process again, but I do want to just kind of introduce the team again that everyone will be working with throughout this program. So my name is Drew Blackwell. I'm with Kavanaugh. I'm the non-revenue water program manager, and I'll ask each of our team members on the line, if they would, just to come off mute. If your camera's on, just wave and say hello, so folks can put a face with the name that they'll be working with at some point during this program. I'll go to Will first, if you don't mind, Will.
Yeah, good morning, and really glad to be back together. I think we were last together, as Drew said, in January. So I'm Will, and I'll be working with a couple of the utilities on the line today in our breakout rooms. We'll be together for the duration of the week in our breakout rooms. So hopefully we'll get to know each other a bit more in those smaller groups, and then obviously as the larger group together, we'll be learning some things in common with everybody in the same room. So good to be here, Drew. Looking forward to it.
Fantastic. Thanks, Will. Let me go to Larry next. Larry, would you say hello, please?
Hello, my name is Larry. I am with the Kavanaugh team as a non-revenue water analyst, and we'll be working in the same way in the breakout rooms as Will just described with you, and looking forward to that. So I'm glad that you're here and look forward to working with you.
Fantastic. I think if Tori's on the line, Tori, would you say hello, please?
Yep. Good morning, everybody. Won't be leading any of the specific breakout rooms. We'll be kind of on and off throughout the week, but available for any questions and support that's needed. So,
great. Thanks, Tori. And Steve, could you round us out, please?
Good morning, gang. Steve Kavanaugh and Drew. I'm on my way to get a decent cup of coffee. So now you're catching me driving. I'm about 15 minutes from being at my desk, and excited to be a part of the program. I'll be leading a breakout session today. Just excited to see the tribal utilities and representatives on, and looking forward to meeting you.
Fantastic. So Steve, just remember the very first part of every successful water loss program is making sure you get to the meeting safely and in one piece. So 2 hands on the wheel and eyes on the road while you are making it to your stationary spot.
For sure.
All right. Excellent. Okay, so folks, what I have up on the screen now is our agenda for day one. So the first segment is I want to introduce just kind of the very large overarching goals and objectives and the format of our workshops this week. So then we're going to be using breakout rooms, as you've heard, and then some ways that we can just make sure that we're testing our comprehension of the knowledge that we're sharing here today. So there's a couple tools that we want to introduce and make sure that everyone can access those before we jump into it and apply those tools. The first learning section that we'll look at today is going to be on the M36 methodology. So we are going to introduce what is known as the water balance. It really is, again, the anchor of using the water audit, the anchor of the water audit software that we'll look at, and the M36 methodology. It's a way really of systematically accounting for all volumes of treated sources going into our distribution system. That's going to be important as we talk about how we're calculating our water losses and how we're further separating those losses out to help us identify where we should focus our attention. So we are going to walk through each component of that water balance as we are talking about the M36 methodology. We are going to have a breakout exercise where we'll have about 2 of the tribal utilities paired up with one of our team members. So we will we'll break that out in the Zoom breakout feature, send everybody off to a smaller group to work together. And that exercise is going to work on drawing our water audit boundary. So before we execute that breakout exercise, we'll tee it up and tell you a little bit more about what that's going to entail. And then we'll come back and we'll round out the water balance and the M36 methodology presentation. We'll have that should take us to our first break or roundabouts. And then we're going to look at the industry standard tool to calculating water losses through the AWWA free water audit software. It's been an exciting time in the water loss industry. The newest version of the water audit software was released in 2020, version 6. We're lucky to have Will on the line, who chaired the AWWA Water Loss Control Committee's software subcommittee, and was one of the key architects to this newest version of the water audit. So Will will walk us through the ins and outs and the updates and improvements to that. So whether you have used a previous version of the water audit before, or you're seeing it for the first time, this is going to be a great introduction into that tool. And then as we're moving through, get closer to the end of the day, we will have a summary review and wrap up. And as I mentioned, you guys will have a evaluation at the end that will speak to ask for your information on your experience in this workshop, in this virtual setting, and then specifically to the content that was delivered in this workshop. All right, fantastic. All right, and I see a couple folks utilizing the chat. So we have plenty of team members on the line today. So if continue to use that, I want to encourage you guys to use the chat feature and ask questions as we move along. And then certainly we will have some places where we can break and open it up for the large group to come off mute. All right, so just want to outline some of our key learning objectives here. So really, after you've gone through the 4-day workshop here, we want to make sure that you guys are equipped and you understand what the key concepts are of the M36 methodology. So I keep saying the M36 methodology, and for those, I know that 2 utilities are still waiting on theirs to come in the mail, but you should have received this manual. This is why I keep referring to M36. It's just the name of the AWWA manual for water audits and loss control programs. Currently in the 4th edition here, and we know this is it's a pretty thick manual. So we're tasked with today and the following days to bring 450 so pages to you and deliver these key concepts and help you guys understand those key concepts. We also want to introduce and make sure you guys are comfortable using the water audit software. That is also developed by the American Water Works Association, and it is the industry standard tool for calculating water losses, not only looking at the volumes of losses in our system, but also how much it's costing us each year. really important component to the tool. Another component to understanding our water losses is on how reliable the data is that we're putting into the water audit software in the first place. The term that we're looking for there is data validity. So that's going to be, as we move into day 2 and day 3 of our workshop, we'll start to introduce how we look at data validity in our system, in our data. And really, it's understanding the practices and policies that we have in place that look at how we are collecting our data, how we're maintaining it, any quality control checks that we have on the data, how frequently are we reviewing it. A lot of things that go into understanding how reliable the data is. Because you can imagine if we have uncertainty in the data that we're putting into the water audit software, we're going to have the same degree of uncertainty when we're looking at our results. So I've said a couple things there of looking at our volumes of water loss, how much it's costing us, and how reliable we are in the data in the first place. That's going to be a constant theme and reminder of how we're going to look at our water losses there. And so now, once we understand those key concepts, we're comfortable with using the water audit software as a tool, and we learn a little bit more about how to understand and identify and evaluate how reliable our data is. Then we want to understand what are the next steps and how to interpret what the next steps are for our utility. Unfortunately, just completing the water audit will not save a drop of water or reduce any costs immediately, but it is a tool to help you guys make cost-effective decisions towards effective water loss management. So those are the high-level key objectives that we are looking to achieve during this workshop. And now this is just a reminder of how the setup of how we plan to achieve that. So again, we met previously in January for an introductory session. Before that, everyone was introduced to the program website. So again, that is ihswaterloss.org. We'll bring that up later on in the session today. But moving from left to right here, as a reminder, after our introductory session, we are now presently at the M36 workshop here. So you can also see the progression of different levels of learning and instruction here. So and it's also looking at the Bloom's taxonomy approach of instruction and learning. So different categories that we're trying to insert at each point along the way: knowledge, comprehension, application, analysis, synthesis, and evaluation. And you can see that it's built upon each task that we have through this program. So for this week, we're going to deliver. We're going to use this approach, providing knowledge of the M36 methodology, the water audit software, how to identify data validity, and interpreting our next steps. Comprehension, we're going to have different points throughout the program where we're going to insert some quizzes, maybe have a little bit of fun, maybe some friendly competition to have a check on making sure that we're comprehending the material here. And then application, that's going to be primarily on the small groups, the breakout exercises that we are going to have today and throughout the week to get hands-on the water audit software and really taking the first step to understanding how to use that tool and start to think about how you can apply it to your own system. Moving beyond this week, I'll just touch on this a little bit, but certainly on day 4, we're going to give you much more detailed information about what are the next steps in the program. But after this week of workshops, we'll move to a coaching phase where at the end of that, you will meet with a member of our team and have what's called a level 1 water audit validation session, where we're working with your audit and looking at your different supporting data and making sure that it's done correctly in the M36 methodology, and that our data validity grades are properly assigned. But leading up to that, we're going to have lots of different regular check-in points with an assigned coach for your specific tribal utility, and then an opportunity to schedule any ad hoc meetings with your coach, who is a member of our team that's on the line today. Schedule a time with one of our coaches as questions come up. So, for example, you may be pulling together some supporting data, and Larry's your coach, and you might just want to schedule a quick 15-minute call with them and ask for a little bit more background, or what does this term mean, or just shoot them an email. Either of those options are going to be available to you guys in addition to regularly scheduled sessions with your specific coach. And that's all to continue to reinforce the learning of that we're going to establish today and this week. Lessons learned. After we do that, we're going to get together on another call together, and that will be where we'll ask you guys to formulate some lessons learned through this program, starting from this workshop, your coaching sessions, and just kind of document that and share it with all the other participating tribal utilities. I'd just say that the peer-to-peer learning and hearing what challenges or what lessons learned that one utility has is probably the biggest one of the biggest benefits to these water loss training and technical assistance programs. Just sharing some of the ways that you guys have collected data or challenges that you have. That's when we hear other utilities talking to another utility on the line or in the training room. That's really that peer-to-peer learning is where a lot of we see a lot of light bulbs go off and understanding ways that different ways that things can be approached. So we'll look at those in the lessons learned session, and then we'll meet again for a closeout training session as well. So this is really just a continuation of lots of different interactions that we're going to have throughout the duration of the program. So specifically today, we're going to be looking at, we're going to be talking through those items and those key learning objectives that I mentioned, and making sure that we are delivering the knowledge base for you guys, and then making sure we're checking to see that everyone is comprehending the material, and then also some points along the way to have some real world application with our water loss activities. So the knowledge is going to be pretty straightforward. That's going to be us delivering some of that training material through these the slides that we provided in advance to you all. The comprehension is going to be the application here is going to be when we go into the different small group breakout rooms. So again, you'll be working with a member of our team, and we'll probably have 1 or 2 utilities per each breakout room. If you've never been part of participated in a breakout room for Zoom, then it's pretty easy. You won't have to do anything. If everything works accordingly, everyone will be funneled off to a separate room with your instructor, and then I'll be able to send announcements like, hey, we'll wrap up in 5 minutes to where everybody can see that, and then we'll come together as a large group and talk a little bit about what we learned during that small breakout group activity. And then I mentioned that we're interested in just tracking our comprehension through this program. So we have a tool that we'd like to use in this workshop. Some of you may have used it before. It's called Kahoot, and it's a funny name, but it's also a fun way to get together and check in on some of these key concepts that we're going to be talking about. So again, there might be some friendly competition going on amongst the tribal utilities or the IHS staff on the line, and that's great. We encourage a little bit of friendly competition. But the first thing in order to do this is to make sure that everyone is going to be able to access this. And we chose this tool because it is a pretty simple interface here. So every time during the course of the program today and throughout the week, when we see this slide, this light blue slide, that's going to be a point where we're going to launch some of these questions through the Kahoot tool. All right, so the first test here is using the Kahoot tool, and I will bring in my screen here. And so before I start this, if everybody has if you have a cell phone with you, that's probably the best way to participate in this. But if you don't, that's okay. You can still use another browser window to participate in this. But essentially, it'll take you to you'll log on to a web address, kahoot.it, and when I launch this, it'll give you a PIN number to enter. And so if you're joining from your phone, you would just type in kahoot.it, and I'll put that here in the chat feature here. And then when I launch this, it'll just give you a simple PIN number to enter and join. So with that, let's go ahead, and I've got a couple tests here just to make sure we can all access this.
I'll just put the link in the chat, Drew, so everybody should be able to
Okay.
click
Great.
on that either on your phone or key it into your phone, or click on it on if you're on a computer in a new browser.
All right. So when I hit start there, you see it says it's loading the new PIN. So what it's asked, what you're going to be tasked with now is joining that link that we'll put in there and entering in that PIN. All right, so we can already see that Brad has logged in there. All right, and Eagle is in there as well. Excellent. All right.
You want people to use their real names, right, Drew?
Yeah, no code names. We want to understand, because again, we might have some there may be some bragging rights at stake. So all right, and as we're learning how to do this for the first time, when we do it the next times, it should be able to log in here. We'll all be pros at Kahoot at the end of the week. All right, great. And if you are having any difficulties accessing it, looks like a lot of folks are coming in now, then just pop your question into the chat, and we can certainly help you get access to it.
Yeah, I'll keep an eye on the chat for that, Drew.
Okay, great. All right, so we've got more than half of the folks, the participants on the line, that have been able to access it. All right, here we go. Great, there's John, Jenny. right, I'm gonna join in on the fun here.
16 so
Okay.
far.
All right. All right, great. All right, so this is just going to be the we have a couple questions here to test this out. If you are having any issues, will coordinate with you through the chat, and but we have a couple test runs here just to make sure everybody is comfortable using this. So we got some easy questions here to run through. So I'll go ahead and start the first one here. All right, so it's just a practice round. Okay, so if you've logged onto your phone, you should see the question and the responses here. So simply just select the what you think is the appropriate response. Okay, all right, fantastic. So for those that are logged into the Kahoot session, it looks like everyone was able to successfully enter their question there. All right, let's do just a couple other practice rounds here. All right, it will ask us to enter in another pin. All right, so pin is 520-0748. Some of you guys have used this before, I can tell. All right, great. I think we've got about the same amount here that we had. So we'll go ahead and I should say, if you are, that's all right, Eagle, that's trivia night at the local watering hole. I should also say, if you're having trouble accessing this, as we move forward and we're doing more of the learning components, this is just fun practice rounds here. But if you're still having access, you can always use the chat function in Zoom to share your answer. So no one will be excluded from using this. But this is just a different way to interact with the Q&A here. All right. So our next question here, as it's getting ready. All right. Topic of this week's workshop is.
This is a tough one, Drew.
Right. I hope this is to make sure we're all in the right place, right? All right. Well, at least most of us are in the right place. Someone apparently is hoping that they would learn how to change a tire, and maybe during the break we can accommodate that. All right. So we are definitely getting the hang of it. Let's just round it out, because I know that Will is working with the at least one or two folks just to make sure they get access to that. And let's hit one more practice round here. All right. Okay. So that pin is 2551952. All right. We got most people on the line. Okay, here we go. All right. We'll go ahead and kick this one off. Okay, this is a different one. This is we're looking to, in a word, describe water loss in your water system, or regionally. So for those tribal utilities, we're just looking for a word or two to just describe water loss in your system. Maybe should have put a little bit more time on it for this one. All right, these are fantastic answers. I love this. So we've got, in addition to some people in the waiting room, we've got bad, balance, okay, minor, complex. I like that one. Unquantified, okay, fantastic. Water, significant. All right, this is great. This is a great start here to understanding how we're looking at water loss in our system. So I would just take a guess here that if we're looking at, if we're looking at water loss as bad or significant or certainly unquantified, then maybe we haven't put in place just a systematic way of quantifying our water losses. So that is one of the key objectives that we're going to try to meet during this workshop, using this industry standard tool of the water audit software, and through this tool using the M36 methodology and the water balance to first make sure that we're quantifying it in a right way, and that we're looking at our results in the right way as well. Our results in terms of volume of water that we're losing and the value that it's costing us each year. Complex is certainly, it's not and on one hand, the water balance is a easy concept, but the best part of our job is that every system is different. So when we're talking about water loss, every system has its own unique setup, unique practices, unique challenges. So everyone is different, and so it keeps it fresh, but it can certainly be complex. Minor, maybe water loss. Maybe we are tracking our water losses, and it's relatively low. Which so if that's the case, we just call it a day and head to the beach, right? No, we'll talk about that. We want to continue to monitor our water losses, and a best management practice put forth by the American Water Works Association is to conduct the water audit on an annual basis. So we certainly in our January introductory session, we talked a lot about what a lot of different states and regions around the country are doing to that respect. So in some places, it's required to submit a water audit on an annual basis. In other places, it's a voluntary activity, but one that utilities are using year over year to understand their water losses and the trend of another term that we'll learn about, of their non-revenue water. So this is fantastic, great start. Thanks for sharing this. And I think actually, if you guys will entertain just one more, I think we have one more question here, and then we will roll into our presentation mode. All right. So one more question here, and see if we've got any other folks that have had trouble accessing, if they can join in here. And if not, again, please feel free to use the chat feature to respond to these. All right, so as you saw, it's not just a multiple choice, but we're going to have different formats for really making sure that we're looking at the measuring the comprehension of the material that's going to be presented here today. All right, so that pin is 4003723. All right. All right, so we'll go ahead and kick this one off. Looks like folks have definitely got the hang of using using Kahoot. All right, so we've got a poll question. Choose your most appropriate response to the following statement. This Kahoot thing is a piece of cake. All right.
I'm slightly nervous how this poll's going to come out, Drew.
You and me both. Okay, good. All right, so most of us are pretty comfortable with this. The others are there. It's new, but we're warming up to it, so that's great. We'll use this throughout the day, throughout the week, to check in and make sure that that we're comprehending the course material. Okay. Fantastic. All right. So thank you all for taking a moment there. That's important, just to kind of work through the logistics of using the Kahoot tool. And again, so every time you see the blue screen that says "Test your knowledge," that's your cue to get the thumbs ready if you are using your phone, or get the gears turning upstairs to make sure to get ready for the quiz questions. All right. So now we'll go into the presentation portion or format here this morning, and we're going to start with the M36 methodology. And as we mentioned, we're going to start with what's known as the water balance. But before that, this is a slide that we always like to start with. Again, you guys have this M36 manual. It's pretty hefty, and about 450 pages or so. But what this slide conveys is our best shot at just kind of condensing that manual down into one graphic. But we think it does a pretty good job. What this is showing is the evolution of or the progression rather, of a water loss program. And through these steps that you see here, we can get better data to make more informed decisions on how to properly invest in our system. So it starts with this first box of establishing a water audit baseline. So understanding the water balance that we're going to go into in detail here, and using that to create your water audit, to populate your water audit. And then through that, we'll also understand how we separate our water losses into what are known as apparent losses and real losses. So just on a rudimentary calculation, our treated sources of supply that are going into our distribution, less the consumption in our system gives us water loss. So that's a pretty simple concept, but just having a single volume still doesn't tell us a whole lot about where the majority of our losses are occurring. So that's where the water audit helps us separate out those different types of losses to apparent losses and real losses that we see there. Think of apparent losses as the water that makes it to your customers in your system, but perhaps we're not measuring it accurately. So our meters are not they're not performing at 100%. So we know that some of our meters have some inaccuracy with them. Real losses, those are the ones that we most commonly think of when we are thinking about water loss. So those are the physical leaks in our system, the ones that are coming to the surface or that are below the surface that we know about, but has different strategies and tools to identify those. So apparent losses and real losses, we're going to learn how to break those down through using the water audit software. Also in this box is a level 1 validation. This is a process that you're going to engage with our team in that task 4 coaching section of the program, but you're also going to get an introduction to it this week. Level 1 validation is a standardized process where you're working with a third party who is reviewing your water audit, reviewing your supporting documentation, and having a dialogue about the practices and policies that are in place in your system to help us evaluate how reliable the data is going into the water audit that's giving us our losses volumetrically and by cost. So we want to do this practice on an annual basis. If we're just creating the water audit, once every 5 years, that's really hard to really understand what our trend of our losses or our non-revenue water is, and it's difficult to make any informed decisions. But using that on an annual basis is the recommended best management practice by AWWA. But there's several other boxes here, right? So there's just doing the water audit. There's a lot of things that you can do beyond the water audit. So I'll cover some of those here because we're also interested as one of those key objectives to help you be able to interpret what the next steps are that will be appropriate to your system. And it's going to look different for every system. Every system's loss profile is going to look a little bit differently. So your next steps or your intervention strategies are going to look a little bit different. So it's not a one-size-fits-all approach. Beyond using the water audit, establishing that water auditing baseline, we can move to a more technical analysis here. So this might look like perhaps a analysis into your billing data, for example. Or it could be some field instrumentation or measurement, like supply meter testing out in your field. But whatever that is, your water audit has directed a little bit more focus towards some additional technical analysis that could be helpful to further defining our loss profile in our system. And that's going to be helpful because we need to find the right tool, the right intervention strategy to the losses that we're experiencing in our system. The third box here is an economic analysis. So once we know where our losses are occurring, we want to understand what is economically recoverable in our system. So to get down to zero loss is not a realistic goal. In fact, we would most likely be overspending to get our system or try to get to zero losses. That overspending could, so that would be a way of aggressive overspending. But most commonly, we see utilities that are overspending from more of a reactionary approach. So only replacing meters when they fail, or only or just a response time with their their main brakes, and just replacing main brakes in a reactive approach. So understanding what is economically recoverable in our system can help us properly invest in the right intervention strategies there, which is that last box. That it could be, it's like I said, it's going to be different for every utility. Leak detection may be the appropriate next step. Pressure optimization, customer meter testing, billing data analysis. All of those things are possible next steps in this water loss journey here, the progression of your water loss program. But you need to take these preliminary steps so we really understand where it is we need to be going. All right, so I just want to walk you through an example, a demonstration of a utility that is tracking their water loss. But we've mentioned that we're interested in looking at our water losses in terms of volume and value. But a lot of folks are still tracking water losses as a percentage. And want to show an example of a utility here that is tracking their water loss as a percentage, and where they can run into trouble here. So just to orient you to the screen, we have a utility tracking their water loss on a monthly basis. The blue here is the water supply volume. In green, we have the billed consumption. I want to direct your attention to the yellow dashed line here. So this is the utility tracking their water loss as a percentage on a monthly basis. All right, so if we are going month to month, they may start to see their water loss percentage start to increase, and so maybe at that point, Eagle is emailing Lynette and saying, "Oh, our percentage is going up. We need to do something about it." But then the next month, it starts to taper off, so we can wipe the sweat off our brow and continue on some other priorities there. But then we see it might start to creep up a little bit. And this is very common if we're tracking water loss as a percentage. It tends to fluctuate quite a bit, and it can be frustrating and leave us really scratching our heads here. But at this point, we start to see it really starting to increase here, where Eagle and Lynette are no longer emailing each other. They're holding a meeting and saying, "Hey, we've got to do something about this, about our water losses. It's really all over the place, and we need to get a handle on this." So in a lot of cases, we see, and this again is very common, utilities tracking their water loss as a percentage, and then what that leads to is jumping straight to, yeah, right, fire drill. You got right on the money there, Eagle. We see a lot of utilities jumping straight to that intervention stage. So bypassing, that baseline of water auditing data, then further understanding their loss profile, and then even doing an economic analysis to learn how to properly invest. So maybe a utility is, maybe they're investing X amount of dollars every year for leak detection, where that may not be the appropriate tool to address losses in their system. So again, back to that 4. This kind of prescriptive approach, where through each step we're getting better data to make more informed decisions on how to properly invest in our water loss program. All right, so this is what we want to avoid, that fire drill, that panic, and we want to make sure that we're looking at it in we're tracking our water losses by volume and value rather than percentage here. We'll talk a little bit more about that as we move through the workshop. So these are the key indicators that we want to look at with respect to our water losses. So our team will affectionately refer to these as the 3 V's, but volume, value, and validity. So the volume, whatever units we're tracking our water losses in, we're able to see that as a whole, but also in a more normalized way of looking at it in gallons per connection per day. That gives a different spin on the amount of losses that our system is experiencing. So again, those volumes are going to be looking at its leakage volumes, but it's also looking at losses that are paper losses or apparent losses, right? So we're definitely losing some revenue on that water that's delivered, but we have an inaccurate customer meter registering that. So we're taking a hit to our revenue there. The value, I think one of the most powerful parts of the water audit software is that we're able to value those different losses, the real losses, which are physical leaks, and then those apparent losses, like the customer metering inaccuracies. We're able to value those differently. So we're not just assigning one value to all of our losses. We're assigning it differently so we can really drill down and understand where our priorities are. And the biggest component to our losses from a volumetric standpoint may not be the same component from a cost standpoint. We may see that at the end of the day, our greatest loss volumetrically is to leaks, but from a cost perspective, the greatest component is the inaccuracy of our customer meters. So it gives us two different ways that we need to look at the results here. And you can see the biggest cog in the wheel here, and that's on purpose, is really understanding how reliable our data is through our understanding our data validity. Again, that will look at the practices and policies within our system. The newest version of the water audit that we'll look at has a great user-friendly and very transparent way of stepping us through and helping us understand how valid our data is. But not only that, but it'll give us some guidance of what we might consider implementing into our system, whatever that limiting criteria is to our data validity. It'll identify that, and so we can look at that and then really assess how feasible that would be to insert in our practices. In some ways, it might be something very easy to implement in your system. In other ways, all of these are going to have a cost associated with it. So it's something that you need that we'll learn how to prioritize and just consider as a way and means to increase or improve our data validity in our water loss control. Okay, so we're going to start here with the water balance. Excuse me. So this is going to be the anchor of the water audit software tool that we'll be learning more about later in this session. But the definition that we have here, the water balance is the summary of key water audit data that shows water management from source to customer, with the sum of the quantities in all of these columns equal and thus balancing. So what this is a mass balance. This is showing a mass balance approach. So as the definition told us, each of these columns that you see here are going to total the same volume in our system. So if we move from left to right, we might have different sources of water. Maybe we're producing our own water, or we're purchasing it from somewhere. We could even be exporting it to a neighboring utility, but our water balance is really going to start there with our treated sources that are going into the distribution system. And then from there, we can systematically account for all volumes of water going into our distribution system, either through measuring, so that's through our metering process, or through some of these uses, we'll need to estimate that. So I know some of the utilities on the line have a significant portion of their customers that are not metered. So in some way, we need to estimate what that is. You guys already have a process in place. So through the course of this program, we'll learn a little bit more about that and how to appropriately relay that into the water audit. But flushing in your system, right? That's not typically not metered or fire suppression. So we need to estimate that in some way. But the takeaway is that we're accounting for all volumes that go into the distribution system. So we're no longer attributing any type of volume or percentage to unaccounted for water. In fact, that's a term that has been abandoned by the American Water Works Association, I think back in 2002, 2003. Rather, the industry now has moved towards water losses, or more specifically, non-revenue water. So I know I'm throwing out a lot of terms there. It's okay. We're gonna walk through each one of these phases here, but it all starts with our water supplied. So we're gonna walk through our water balance and move from left to right here. So water supplied, we'll just take a look at this definition here. So volume of treated and delivered water supplied to the retail water distribution system of the water utility. It is equal to the volume from own sources plus the volume of water imported or purchased and supplied from a neighboring water utility or regional wholesale water authority, minus the volume of water exported and sold in bulk to other water utilities during the audit period. So water supplied encompasses a lot of different possibilities or considerations. Your system may be producing all of your water. Maybe you have a handful of wells. Maybe there's a treatment plant. Maybe it's a combination of both. Or you could be purchasing all or some of your water. All of these are components of water supplied, but that is the water supplied is the effort to understand all the treated sources that are entering your distribution system. It's going to be actually the most important number in our water audit, because everything else in our water balance and our water audit kind of hinges on that water supplied number. It's the starting point of our water audit. So we'll want to take great effort to understand that we are getting the most accurate water supplied number when we're looking at our water audit that we can. All right, so just another way of looking at our water supplied. It's our volume from own sources, which is water that we're producing, plus, if it's applicable to your system, plus any water that we're purchasing from a wholesaler or another system, minus any water that we are exporting to a neighboring community. So this is all looking at treated sources. So the water audit is only interested. The water audit that we're going to be working with is only interested in potable water. So we're going to exclude any raw water or reclaimed water in this process, in this approach. All right, so there's a couple of variables there: volume from own sources, water imported, water exported. So let's make sure we define those. Our volume from own sources, it's the volume of water withdrawn from water resources. So anything that you're grabbing from surface water to groundwater wells, and you're treating that So it's controlled by the water utility and then treated for potable water distribution. Most audits are compiled for utility retail water distribution systems. So this volume should reflect the amount of treated drinking water that enters the distribution system. For this, the sources that we're looking at are volume from own sources again, groundwater sources, surface water. Your system may have a combination of those. You may have a well field that's feeding into a treatment facility. You may have wells distributed evenly throughout your service area that treatment is occurring on site, and the treated sources are pumped directly into the distribution system. The setup is going to look different for everyone. One thing to consider is, which meters are we using? In a little bit, we'll go through an exercise where we need to understand where that closest point of entry into our distribution system is that's capturing the treated metered sources of that water that we are producing or purchasing. So understanding you might have a raw water meter, it might feed into a treatment facility, and then you might have an effluent meter capturing that treated source that is going into your distribution system. We need to identify where that closest point of entry is of those treated metered sources to really get an accurate water balance and water audit. So which meters are we using? Where are those meters? Those are all things that we'll be talking about and learning more from you guys in our exercise coming up in just a bit. All right, so that's our own volume from own sources, water that we are producing in our system. So now we're going to talk a little bit, show a little bit about our water audit boundary. So again, just one scenario, we might have 3 different groundwater wells. We might have a treatment facility where we're taking surface water to raw water and treating it in that treatment plant. And then eventually those treated sources are entering our distribution system. So when I mentioned, where are those meters and understanding where that closest point of entry is, we want to understand where those meters are, where they're located. So drawing out a schematic like this is going to be often the first step of understanding where we start our water audit boundary. Our water audit is really going to be bound by 2 main things. The parameters of our system, where the treated sources are entering the distribution system and leaving the distribution system. And also, so that's the first one, also time. The water audit is looking at a 12-year time period, typically either a calendar year period or a fiscal year period. Time and space there are the 2 things that our water audit boundary is bound by, and this is the first step of establishing our water audit boundary here. Where are those closest points of entry? All right, so our water. So another part of our water supply is water imported. Anyone on the line purchasing their water from the system? I don't have all the camera windows up here, but maybe if you just give a thumbs up in the chat, I can see if anyone is purchasing any water in their system.
You might be looking for the thumb, Drew.
Okay.
We got one confirmation for Pechanga on
Great.
some purchased water.
Great. Okay, so when we're purchasing our water, okay, so Pechanga's purchasing around 20 acre feet each year. All right, Ross, in one of their systems, they're purchasing the water. And that's important to know because first of all, we want to understand you know, where that we understand the way that water is being measured. So if we're purchasing that water, are we getting those volumes from the exporter? You know, how often are those? Is that meter read? Is it tied to a SCADA system? Is that meter being tested at all? And if so, what type of test method are they using? How frequently do they do it? But also, if you're purchasing your water, that also think of a scenario where a system is purchasing all their water. That's also going to be how we're valuing the leakage in our system. So not to jump too far ahead, but if we lose water physically to leaks into the ground, what do? We pump more water into the system. So if you're purchasing all of your water, that's how we're valuing the leakage there. So if you're a purchase only system, it would maybe for Ross's one system there, then your leakage can be more expensive versus if you're producing all of your own water. So just something to consider. It sounds like in Pechanga they're purchasing some, but also producing some of their water there. So it is a component of our water supplied volume that we need to understand. All right. So there's some of those questions that we need to ask ourselves. Who are we purchasing the water from? Are there any agreements in place? I mean, certainly there's some agreements in place, but specific to the water audit and how we're understanding how reliable that data is, are there any obligations in those agreements to with respect to meter testing, and general meter maintenance? Understanding the meters, that the closest points of entry into the distribution system, making sure those are the meters that we're working with when we're pulling together the volumes that go into our water audit, and how that water is tracked. Are we taking manual reads, or is it tied to a SCADA system? Are we doing both? And just understanding a little bit better about how we're collecting that information. All right, so if we go back to our water audit boundary schematic here, so we know we have a system that might be producing some of their own water, either through that treatment facility or treatment occurring at the two wells down here, well 2 and 3, and feeding directly into the distribution system. All right, so there, now if we're just looking at our water imported, so that's some water that we're purchasing. And so that is usually coming directly into we're purchasing the treated sources that are feeding directly into our distribution system. So there may be a meter on the exporter side. There may be a meter on the utility side. So we need to if that's the case, we need to understand that and understand where we're collecting those volumes from. All right. And some of you may be exporting water to a neighboring community. Usually that's a smaller part of our water supplied profile, but our water exported is the bulk water that's purchased by a utility to become part of the supplied volume. And that's typically where the water is purchased from a neighboring water utility or regional water authority and is metered at the custody transfer point of interconnection between the two utilities. So some of the things we want to consider there with water exported are the bulk water sales. Are these supplements to raw or reclaimed systems? Always, which meters are we using here to understand which ones we need to collect those volumes from, and how is that water exported tracked? These could be a little bit different from your larger supply meters. These could be smaller meters that are delivering that water to a neighboring community. So maybe these meters are read and tracked differently than we're tracking our larger supply meters. So it's important to understand that. That'll be important to the task of identifying how valid that data is. But water export is typically a smaller volume there, with either volume from own sources or water imported being the larger volumes making up our supply profile. So our water exported here. So that's really us delivering water to another system. And if we're metering it, we want to make sure that we are understanding where that meter is. We're using the correct meter, and also how we're collecting that data to inform how certain we are in the volume that we're putting into our water audit software. All right. So before we, our next step here is we've kind of drawn this water audit boundary out. This is, just a simple schematic here, but through this program, we're going to be learning more about your utility, and really the first place to start is understanding where our water audit boundary needs to be drawn. And as they say, a picture speaks 1,000 words, and having a schematic, no matter how simple or how complex, is a great starting point for our team to begin to understand where we need to begin the water audit and the water audit boundary. So we're gonna do a common exercise here in just a moment, where we're gonna separate out into breakout rooms, and your instructor is gonna, we're gonna have a conversation and start to sketch out your water audit boundary. But before we do that, I wanted to pause there for just a moment and see if there are any questions from the attendees on the line with respect to our water supplied. So that's either volume from own sources, water imported, volume from own sources, water that we're producing, water imported, we're purchasing it from an exporter, or water exported. Any questions on how we're defining those, and then perhaps any questions on why it's important to understand where those meters are that are delivering those treated sources into and away from the distribution system.
Hey, Drew, this is Eagle.
Yes.
Hey, yeah, I just so you know, I had my hand up. Just I don't know if you could see it or not, but yeah, I did have a quick question about the boundaries.
Yes.
So one thing that you had mentioned is water exported, and our system is set up in 3 pressure zones that are equally divided by pressure reducing stations. So there is a possibility where water can flow from one zone to another if the conditions were correct.
Mm-hmm.
But my question was, we have a booster station that, in my mind, it didn't really click until you mentioned it this morning. In my mind, could be water exported from one zone where we produce and purchase water, moving water to another zone onto the reservation. And my question was, would it make sense, instead of trying to have one large audit, but maybe to have 3 smaller audits that kind of separate these pressure zones out?
Yeah, that's a great question, Eagle. I'll start, and then I'll open it up to the rest of our team to add anything. But first of all, the water audit is designed to encompass your entire system, so your entire service area and pipe network. Now, a follow-on task that many systems have taken on is to do exactly what you just described, to separate out different areas of their system an effort to identify their losses. So for example, maybe you have three zones, and you know that water loss could be one zone could be problematic with you could have a high level of losses in one zone. So you want to isolate that zone and even perform a water balance for that particular area. So that's a process commonly referred to as district metered areas, where we're isolating different zones of our system and conducting this water balance in those zones. But in this first, the water audit is designed to encompass your entire system, but that is an option that's out there. Maybe I'll open it up first if that addressed your question, and then maybe open it up to the rest of the team members to add a little bit there.
Yeah, I think that answered my question. Thank you, Drew.
Okay.
Drew, I'll just add a thought, and Eagle, you and I will be together in our breakout rooms, so we'll be able to talk a bit more in detail about your specific setup. But so that everybody else can hear this, if you've got the data to do a water balance at the zone level, there's a tremendous advantage to be able to do that. And Drew just named it, as you can see the loss performance at a more granular level, and you can know that zone 3 is doing better than zones 1 or 2, and zone 2 is the one that's having the most trouble, and that's where you should focus your attention. So it can be very powerful. The caveat is if you have the data. So if you have measurement of supply into that zone, for example, at the booster station, and if you have the ability to distinguish customer consumption in zone 2 versus customer consumption in zone 3, and unmetered estimations like hydrant flushing in zone 2 versus zone 3. So you have to be able to tell and distinguish between type consumption in each of the different zones. But if you can do that, it is very much a powerful exercise to do that, for sure.
Yep.
Sounds good.
Great.
Thanks, Will.
Fantastic. All right. Okay, so let me just one more pause to see if there are any other questions from the attendees on the line. All right. Let's see. So the next step here is looking at get my windows open here. All right. So our next step is a breakout session. It's going to take just a few minutes to tee up here and get everybody to the right area. But what our goal here is in this breakout session is to draw your utility's water audit boundary. So working with our team member, we will want to understand, first of all, are you producing your water, purchasing your water? Are there any water exports? And then we just want to map it out to understand where those meters are, and how many meters we're working with, and understanding where those treated sources are entering our distribution system. Before we jump into more presentation parts of the workshop today, I'll maybe just in the interest of time, I'll ask each of the instructors to go around and just give kind of a quick snippet of what their breakout room entailed as far as the water audit boundary. I'll start by just a couple observations with our group. The first observation is we don't always have a meter that is registering the treated sources going into our distribution system. In one case, we had 3 well meters. Treatment was occurring at the well site for one of those meters, and for the other 2 meters, they were feeding into a treatment facility and then fed directly into the distribution system, but no effluent meter registering the treated sources leaving that treatment facility. But those 2 well meters feeding into the treatment facility did have a meter metering that raw water from the well site. So that's the best available information we have to go off of. So we'll use that. So I think that's probably the key observation in our group was just acknowledging that we're not always going to have a meter that's registering that treated flow going into our distribution system. Larry, let me go to you next, and if you have just a tidbit you can share with us from your group.
Yeah, sure. Mine's going to be really brief because we were looking at 2 utilities that had very similar systems on their supply side of the envelope, and so essentially groundwater wells and a meter, just one common meter that represents all their supply volume. And from there, it obviously got a little bit more interesting. But on the up to that point, we were able to do a pretty simple schematic, and didn't have really any surprises. So that was sort of our brief summation of our breakouts.
Fantastic. Thanks, Larry. Steve, how about your group? You said that group 2 was the best room. Room 2 was the best room. So tell us what you got.
Couple quick observations. One, we had the full complement of the utility services covered in the room, which was great. We had billing, distribution, management side of it. We ended up doing 2 systems. Probably the biggest takeaway is the utilization of raw water meters in our second system that we worked with, as opposed to the available finished water meters. So we had a really good discussion about that. But really straightforward, clear boundaries, fairly easy for folks to get their hands around. So that's what I would report from infamous group 2.
Fantastic. All right, Will, how about rounding us out in your room?
Well, Steve, it's not a competition. We like to say that, but let me show you what we came up with.
Oh, give the man a screen and this is what happens. Wow, impressive.
We were fortunate that both utilities had some type of schematic already, and so what we did was we used that and we annotated it with where the active wells are in blue, purchase meter in green, some inactive wells in gray. And one of the coolest parts that came out of our discussion is we realized, to Eagle's original question, they can do a water audit for the whole system, but they can also do a water audit for 3 distinct sections of the system based on how water is measured and moves between 3 zones. So that's going to be pretty powerful. And we actually, in Trish's system, we're going to be able to possibly do that as well. And that was on the second one. So our session was very informative in talking through and drawing it out.
Great. Well, I was going to say, if you drew out what you just showed on the screen in that amount of time, I was going to be humbled.
Yeah, I can't take that much credit, Drew. I had some information to start, but
gotcha. All right. Well, Will, I'm gonna ask you to pick us up here on the water balance and carry us through, and then pivot over to our next test your knowledge before moving to the water audit software.
Okay, very good. And check me on that. We're going to do water balance, Kahoot, test your knowledge, and then software. Great. Thank you for that. Thank you for that, Drew. All right, well, let's jump in, and Drew, just kind of watch my time in the chat and let me know how we're tracking, and I'll try to stay on time as we go.
I will, but Will, you got a other screen share for the presentation part. There you go.
All right. Let's go to share the right screen. I guess I should do the one with my presentation on it. That would help, wouldn't it? All right.
There you go.
All right. Thank you, Drew. So I'm going to kind of continue the discussion of the M36 method that Drew talked about. He got us thinking about earlier, thinking about the water balance and the different components. And then we did our, discussion around the boundary, and that got us to those breakout rooms. And we're now thinking in terms of our specific boundaries for the specific water systems. So now I want to carry that thought process forward, a roll here, to once we know what our boundary meters are, then we can consider how we're translating that math into the water audit entries. So remember, those boundary meters are the beginning of the math. That's where the water balance begins. And so we have this concept of water error that can live in those meter readings. And any known error we want to actually make an adjustment for in the audit, and there's a place to do so. And this is defined as an estimation or measure of the degree of inaccuracy that exists in any of those master meters. We'll also call them boundary meters in the annual volume, either from own sources, imported or exported. And any error in the data trail, the recording of that information where it gets archived. If there is any error in that and it's known, then that can be corrected for. And so this adjustment ends up being important because not all meters are perfect, not all data recording processes are perfect, and you want to try to account for any of those known errors. We want to consider a couple of questions in doing so, and those questions we want to consider are the accuracy, sort of the inherent accuracy of the meters that are installed. And we can assess that through two different and distinct practices. One is electronic calibration, and another is volumetric accuracy testing. These are terms that you're going to hear quite a bit as you go through this process with us. And we'll be learning about it. We'll be even asking you some questions about things you are doing. I know already that there are some participants in the program that are doing some of these things. You may not be doing any of these things, and that's okay. But part of the goal of the program is to kind of bring everybody up to a common level of knowledge on what practices are considered best practices, and then either enhance what you're already doing or start doing something. So in thinking about that, we want to really dial in on those boundary meters in particular, because those are the ones that we are utilizing to start the water audit. So for the purposes of auditing, we're less concerned with the testing and calibration practices with the non-boundary meters in this similar illustration, these raw water meters. But for these that are feeding the top number, the starting number for the water audit, we're very interested in that. So let's think about some different ways that can translate and types of activities you can do. So for source meter testing, one example is something known as insertion type testing. And this is something that involves making a small tap in the line somewhere near the meter that you're trying to test, and installing a temporary probe style or insertion type test meter to be able to conduct a test. And that gives you the test meter that you're introducing, the subject meter that's already there, that's the utility meter. And now you have two different readings that can be compared, or two different volume measurements that can be compared. And this is considered one of the best ways. There are other ways, and we won't get into it today, but we'll learn about those a little bit more in this program a little bit later. But this process can lead to results that could get you, if let's say you had 3 supply meters, maybe similar to the breakout room you just did, and maybe you have 3 wells. Or 3 different points of supply metering that are entering the network. Each of those 3 meters may represent a different volume of the water supplied into the system. And that actually means that each of those boundary meters carries a different importance. In this illustration from an example utility, meter number 3 is not nearly as much as meters number 1 and 2. You can see clearly meter number 1 measures most of the water going into the system. Well, if a meter accuracy test is conducted on each of those 3 meters, we can get to a accuracy result for each of the 3, and positive and negative matters here. This gets into whether or not a meter is under registering versus over registering, and that's always important to consider. But here we can see we had meter number 3. It actually was performing fairly poor. It was very much under registering, 15%. And then we had one that was just under, and then one that was a little bit over. Not doing great, but a little bit over. Well, how does all of that translate into a single result or a single error adjustment in the audit? And that's where we want to introduce the notion of a weighted average calculation that takes into account the appropriate weightings for each of these. And it's basically, think of it as how much of the pie does each of these represent. And so you want to put the appropriate weight on each of those results. And that's a fairly straightforward calculation, and we'll guide you on how to do that. But the important thing is to not take the three numbers and take the simple average, because in doing so, we would be giving more credence to the results from that third meter than we should, because it's really not nearly as important relative to the error in the water audit. So that's an important aspect about making an allowance for known errors, and that's where you see in this total system input, that allowance for known errors is what translates the system input volume into the water supply volume. And of course, if we have any exported removed, that comes into play there as well. So let me pivot now to authorized consumption. And some of these concepts I think we did actually touch on in the January kickoff meeting, which is great. And it also is helpful, important sometimes to have a little bit of reinforcement of these concepts. So if this sounds familiar at all, that's a good thing. Hopefully it does sound at least a little bit familiar as we're talking through these concepts. Authorized consumption, defined as the water taken by registered customers, those customers that have permission to utilize water from your network. The water supplier, so it could be your own uses, is also something that can be considered authorized. And others who are authorized either explicitly or implicitly to do so for uses of the typical types: residential, commercial, industrial, agriculture, whatever the case may be. Key here is it's authorized, and that's always the very first question you want to assess when you're considering some type of consumption and how to categorize it. And what we see in the water balance is that we have subcategories of authorized consumption, and to be able to distinguish how we handle different types of consumption in the audit worksheet and ultimately get to a good, reliable water balance, we want to ask these questions and categorize things correctly. We want to always be on the lookout for non-potable volumes and make sure that those are not included. The example I shared from our breakout room, there actually is a reclaimed water line coming in that feeds some golf courses. And so we had a little discussion around that's great, and that can be audited separately, but it definitely needs to be excluded from the potable volumes that we're tallying. Finally, is it billed versus not billed? Is it metered versus not metered? So you may have some authorized but not billed consumption. Every utility typically has some of that, and we can talk about some of those examples. In this water balance, we now are dealing with this overall. This is the box that we're dealing with. So all of these above the midpoint in the water balance are different types of authorized consumption. You can see it breaks down into types that are billed and unbilled. And even the billed further breaks down, and the unbilled further breaks down into metered versus unmetered. End of the day, it's helping us understand how much of the total system supply that goes in translates into revenue water versus non-revenue water. But you can't just get there. You have to understand the billed, non-billed nature of each of these categories. And that's how we're approaching those key questions of billed versus non-billed. So with the billed authorized consumption, quite intuitively, it's any authorized water that's billed. that's why it's named billed authorized consumption. It can include both metered and unmetered, and this does get to some of the things that are unmetered. Even participants in this program have some unmetered customers, but even if you're a fully metered system, you may have some unmetered uses, like anytime you have to access a fire hydrant for any reason. And those reasons could include flushing lines for many different purposes. It could also include fighting fires, training and equipment testing with fire departments. Anything that's accessing the network, typically through a hydrant, that may be unmetered. Of course, unmetered connections that are authorized would fall into that as well. So metered, unmetered is an important question. And again, with billed authorized consumption, we want to make sure that we're always looking at making sure it's an authorized use. And when you're developing this number, to either you're pulling it from perhaps your billing software or whatever billing record keeping system you've got, you're always looking for these questions of potable versus non-potable and making sure we're excluding non-potable. In doing so, we also want to discern billed versus unbilled. And that kind of gets back to, it's really a game of categorization. And you've got many different uses and it may be reported in different ways, but ultimately you need to be able to translate it into these handful of boxes. And that's what we're going to do working together in this program, looking at your data and helping you to make sure those numbers are migrating into the correct box. Consumption billed versus unbilled, metered versus unmetered. Again, those are the key driving questions that help us define. Billed, metered, authorized consumption. I think we covered this one pretty well. It's that first box up top. Well, the very first box is water exported. Some folks don't even have any water exported, and so it may be a quick not applicable for your scenario. If you do, you handle that separately from sort of your other retail customers. And so that gets quantified and handled above the regular retail customers on the worksheet. Once you get into billed metered consumption, that's where you're really getting into the rest of your regular customers. And again, Trish, I know in your system, we don't have meters on the customers, so yours is one that we'll handle a little differently, and we'll have another category, which is actually the next one for our unmetered but authorized consumption, and relies more on estimates, obviously, than metering readings. But for others who are either partially or fully metered, this will be the largest box in your consumption box overall. What we are going to be working with you to get in terms of the data is trying to represent month by month for the 2021 calendar year, how that breaks out into different groups. And you may have more or less, your data may more or less look like this, and be assured and comforted that we'll work with your data in kind of whatever format it is in. So if what we're asking for and what you have don't look the same and don't match, just let us know and we'll work with what you got. But this is important to be able to try to separate out the different monthly volumes and then broken out by use type. That gets important to be able to distinguish different categories in the water balance, billed, unbilled, but also looking for non-potable uses and making sure that those are excluded. Helpful notes down below may come into play when you're organizing your water audit data. And any assumptions or any background information, whatever notes you put in there, just know that we will read them, and anything you want to include in the information you send. Drew, I don't think we've actually put a formal data request out, so this is giving everybody a little bit of a hat tip to what we're going to be requesting from you as a result of our time together this week. And then you'll have a healthy amount of time to work on this and get back to us. But this is what some of that will look like. Billed and unmetered, this is again getting to that other type of category. If there are not meters on some customers, then it has to be billed on something else, billed on something other than a meter reading. That may be an estimate. Sometimes it's a flat rate, and it can vary from utility to utility. But if you have any of this, this is the category you want to represent that type of consumption in. Here's a very simple example of a system that had flat rate residential, and you can see they don't have meters there, and therefore there's no variance in the assumed or estimated consumption, but it does have some baseline to base that quantification on. In your system, if you have any of this, what we'll probably do is work with you to understand what the different circumstances are, maybe how you're coming up with those estimates, and whatever data you have to back that up, or if it's just more talking it through with us. We'll work with you to then document it together. So just know that it works if you have it already documented, or we'll work together with you to document how those numbers are getting quantified. Unbilled is the other half of authorized consumption, and hopefully it is not the biggest half of your authorized consumption, or the larger portion of your authorized consumption. But in looking at these areas, we do want to understand if any of this is occurring, and it does typically exist in most utilities, as I mentioned. You know, most systems do have their own uses. Maybe it's a public works facility, or maybe you're testing your hydrants every so often, and you have a hydrant meter that you deploy. So maybe you measure that water, but it's not billed. Or maybe in this category, you've got some of your own uses that you don't meter. Maybe you make an estimate. Fire departments have access to the system for fire protection and safety. That would typically fall into this category. So it's defined as anything, again, that's authorized, and that's a key definition here. It's got to be in that authorized for any reason, but it is by utility policy unbilled. We're going to be very interested in the course of this program and our time together to learn what does that look like in your system. And it can be anything from everybody on the council gets free water, we've seen, to churches and charities get free water, to nobody gets free water, everybody pays. So it can be a whole range of policies that dictate what is unbilled or not. With that, let me pop on to this quick example of the unbilled but metered operation here. And you can see this particular utility had a plant. They had some amount of water that it's metered and consumed every month for operational needs. And they also have a couple parks, so the city irrigation. And so they were able to distinguish that. And it's really only a couple connections. In this case, broken down by class, in this case by use type, by month. These are, by the way, excerpts from another resource that you'll be directed to and be made available to. It's actually a free resource from the Water Research Foundation. It's a complimentary reference manual to the one that you're getting in the mail or have already received in the mail. Drew, you'll have to pick that up later if we're going to talk a bit more about 5057 or not. I couldn't remember how deep we were going to dive there. So unbilled and unmetered authorized consumption is that last category. And I've named some examples: firefighting, flushing, street cleaning. It's really anything that's using water. It's not getting metered, but it is authorized. And that's a key component. I actually have not ever met a system that didn't have any of this. Everybody typically has some. You need to flush water for water quality purposes, chlorine residuals, dirty water complaints. I mean, everybody's got operational needs. So the real trick is are you tracking it? That's sort of a starting question. And secondarily, are you making estimates on those tracking? So maybe you're tracking when it happens, but also want to be looking at, well, we did a flush, 10-minute flush, we'll make an estimate on gallons per minute, and we can put a best guess on the water utilized for that flushing event. And that just goes in the log. And then those can be added up over a month's time and then at the end of the year. So this is something we do encourage folks, if you're not already tracking it, to just simply start tracking it. And there is a default built into the water audit tool, if you're not tracking it yet, that you can utilize to put a starting number on this. So don't worry if you're not tracking it. We got something that you can use for now, but we'll also guide you on how to track these types of uses moving forward. We've named several of these. New construction flushing, I don't think I named that one, but you can see there are a number of reasons why you might open a hydrant and do some flushing. And there's probably some reasons that aren't even named on this list that you may have in your system. All right, that was our break. We'll keep on cooking through. Our break was before that segment. So that moves us into the lower half, the darker half of the water balance, which is our water loss section, and we get into the term water loss. itself. And so let's define it. We're going to define it at a high level and work our way down into the detail from there. Water loss in its most simplest understanding is what your supply is minus your authorized consumption. Drew described it well, and the water balance is all of these columns add up to the same volume. So you get your total system input, allowing for known errors. That becomes your 100%. If you have any water exported, it gets removed sort of out of the math, and that gets you to a water supply. But that total system input, and then your authorized consumption, the difference between those two numbers mathematically is your water loss. So that we're using that as a principle to then start to define what the total loss is, but we have to then further define what's happening underneath that total water loss box. Because just simply knowing that I have X amount of loss in total, that's not enough information to make a good plan on. You have to dial that into the types of loss that are occurring. And that's where we get to the basic concept, our water supply versus water loss. That gets to these subcategories, and we'll take them one at a time and define these. And I think we may have touched on this in a very high level on the kickoff, but let's go a little bit deeper with it, because this is important for us to understand as we're building out the water audit. We're going to need to make estimations of this category now we call apparent losses. And in doing so, let's understand what they are. Those losses are anything that's attributed to inaccuracies with meters. So if you have a meter under registering, it's not catching everything that's going through. It could also be systematic data handling error. That could be a meter that's maybe not programmed correctly to convert from the units it's reading to the units in the billing system. Maybe there's a systematic data issue that's causing the consumption to be messed up and to be erroneous. It could also include a third example, which is theft. And if water is being taken without permission from the network in any way, that's defined as theft, and that's a type of apparent loss. Key distinction here is that it represents non-physical losses, and it means you're missing revenue. And it can also, it ends up skewing your understanding of the consumption data, of how much water is truly being consumed. We're going to differentiate this from real loss in that way, that real loss is physical loss, apparent loss is revenue loss. You're not getting paid for it, but it does actually reach an end user. So an under registering meter, it still reaches the user, it just didn't measure everything that got to them. A data handling issue, it still reaches the user, it just didn't get translated correctly for the billing purposes. And of course, theft actually still reaches a user, they just didn't pay for it, or maybe they didn't pay for all of it. So all of these are, that's a good way to think about apparent losses, different from what we'll talk about as real losses. Is this isn't water that's going into the ground. It's water that is not getting to translation of revenue to you as the utility. All right. When those three examples that we talked about, unauthorized consumption, that can look like anything, and it can look like everything. Drew, I don't know if we have a built-in breakout for people to tell war stories about their best theft instances, but I know we collect them as we go through these types of training and classes and programs over the years, and we've heard quite a number of stories. One of the key things is that theft can happen at the hydrant. The theft can happen at the meter, and it can also be direct tapped off of the service line with a jumper or a pipe around, or opening a bypass valve on a commercial connection without permission. Any of those things would constitute theft. Anybody doing something that's tampering with the meter, opening a hydrant, something without permission, that's going to fall into these. And those are the typical types of examples that we see. For customer metering inaccuracies, this is example number 2 in apparent losses. Anything that causes the meter to under register. Typical examples are wear and tear. Meters wear out, they may read slower, specifically with mechanical meters, that's true. Some of the newer technologies may do better with that. However, meters can also under register if it's the wrong meter for the application. So if you have a turbine meter, which typically does well at consistent high flows, and you put it in an application that has lower flows or variable flows, then that turbine meter is probably not going to give you 100% performance. It's not going to fully measure everything that's going through it, because the meter itself may be fine. It's just it's the wrong meter for the job. So customer metering inaccuracies are something that typically are going to be the largest part of everybody's apparent loss situation. So in the audit process, we'll be examining that a bit more closely together. I talked about meter wear, talked about the wrong size and type. If it's put in wrong, that can also contribute to the meter not performing. Water quality can sometimes affect degradation of the meter performance, and of course, if it malfunctions and stops. So those are examples of apparent losses, and you see over here, those three categories kind of go with that. And so in that, when we categorize apparent losses, that same process of elimination we employed before to get to total water losses, we define total supply, we define authorized consumption. This becomes what's left over, because the water balance, all columns have to equal. Well, we sort of use that same concept of apparent and real have to add up to water losses. So when we estimate this box, what we get is the real loss volume, and that becomes a total real loss volume for the year that's dictated or reported out from the water audit, annual water audit. This is leakage. This is the type of loss you're probably intuitively used to thinking about. Physical losses from the pressurized system. It also can be water escaping from the tanks, but anything from that boundary meter, anything that happens between those boundary meters and the customer's meters or the point of custody transfer. Trish, in your scenario, it would be wherever the customer is responsible for it from that point on. If there's not a meter, maybe it's the property line, maybe it's the edge of the building, whatever the case may be. But anything that happens there is that's a physical loss is going to fall into this real losses box. And this can be at the main, it can be on the service connections. I mentioned it can also be at the tanks. But this is again distinguished from apparent losses in that this is actually leaving the network and it's not getting to a user. It's going into the ground, and it's a wasted resource. And so you're not missing out on water revenue on the water bill, but you do have a sunk cost in what you invested to treat that water and to pump it into the network. And you have some cost that could be saved if you could reduce that leakage. So we'll talk a bit more about the cost aspect of that a little bit later in the program. So all of that gets us to this idea of non-revenue water. And this non-revenue water is the difference between what we supply and what we sell. It also can be added up of these three boxes right here, because every bit of leakage does not translate into revenue. Meter under registration theft and data handling errors, they don't translate to revenue. And if we have authorized but unbilled uses, they don't translate to revenue. So this is the definition of non-revenue water, is the sum of these three boxes. And when we are looking at the water audit results at the end of the process, what we're really after is to identify where in this profile for non-revenue water is the greatest opportunity to reduce. Sometimes it may be here. There may be a more efficient flushing program we can do. Sometimes it may be here. We may have customer meters that are under registering and we can either repair or replace them. Or it may be here. It may be leakage that we can reduce and improve our non-revenue water. But what you're starting to see now is loss overall and non-revenue water as a broader concept. It's not just one thing. It's multiple things, and we really need to figure out which thing is the most costly to us and where's the most opportunity to improve. And that's sort of the focus of it. This helps us to shift away from the old mindset of unaccounted for water, where we take what we pumped and we subtract off what we sold and we get this number and it's a percent difference. That single number philosophy, it's not the right way to do it. It doesn't tell you enough information. And that's where this best practice from M36 kind of got to. So non-revenue water we defined. Graphically, we're understanding on our water balance that that's again the sum of unbilled consumption, apparent losses, and real losses. The water audit tool presents it in something like this, and we see the non-revenue water components side by side, volumes and values, and we get to an understanding. In this case, the volume doesn't always equate to the proportion of cost or the value of that aspect of non-revenue water. It'll be very interesting to see how our different tribal utilities results shake out, because it's a very system by system situation. And the reason for that is that your costs and your water rates are unique to your system. So what it costs you to acquire water, Eagle, in our breakout room, we talked about you purchase some of your water from Met, and that's expensive water. And so that actually makes some of your leakage more expensive versus somebody who's simply on a couple wells, Trish, like you are, and you don't have any purchase costs. So leakage is going to be per gallon or per million gallons is going to be less expensive per unit rate. But at the end of the day, we're trying to get to what is the water loss and what does the total non-revenue water profile look like, and what are the most expensive parts. That helps to prioritize our activities and put us in a really good position to make decisions. Where do we want to focus our attention for the next year, for the next 3 years? Well, it matters on what's our most expensive problem. And we use the water audit to help us answer those questions and make good plans. So Drew, I think this gets us to our interactive point, if I am not mistaken. So I'll ask you to maybe step in here. Are you going to drive the Kahoot to help us with this portion of it?
Yep, you're absolutely right, Will. Thanks for walking us through there. I like how Will walked us through the water balance. I mean, we all understand, the water that is the revenue water, and then what water we're not collecting revenue for, and all those parts in between, the supply and the revenue water and the non-revenue water, that Will walked us through, the authorized consumption, whether it's billed, not billed, metered, not metered, and the different types of apparent loss. Those are all those components that are going to be important to understand as we move into populating the water audit. But now we're going to turn towards our comprehension part of the water balance that we just learned about. So as a reminder, I went ahead and put the Kahoot address in the chat, so you can kind of get ready and familiar with the way we were running that. And I'm going to go ahead and launch the first one here. So we're going to test our knowledge on the water balance here. And so, as you can, go ahead and visit the Kahoot address and plug in that first PIN number there, which is 984-2430. All right, and we got most folks logged in there. All right, so we'll go ahead and open this one up. All right, the American Water Works Association Manual for Water Auditing and Loss Control Programs is also referred to as, this is going back a little bit, all right, excellent job, everyone. Oh, wary. Okay. All right, let's go to our next question here. So the next question pin number is going to be 239-1788. 239-1788. All right. And we got everybody. There we go. Otis just popped in right under the gun. Okay, go ahead and launch this one. And as a reminder, feel free to, if for whatever reason you don't have access to the Kahoot application, then you can always just pop your answer into the chat box in Zoom. All right, the water audit data shows water volumes from source to customer with the sum of all columns equal and thus balancing. All right, let's see what we got. All right, haven't managed to trip anybody up yet. You guys are right on it. Okay. All right, looks like we got some leaderboard here. All right, so for the next one, let's go ahead and enter in pin 102-3759. All right, 13 seems to be the magic number for participation here on the Kahoot. All right, the term that accounts for supply meter accuracy test results is called. All right, so the technical term for that is the master meter error adjustment. Will talked us through that we might have 3, 4, 5, 50 meters. It doesn't matter how many we have, but if we have test results or test accuracy results for all those, there's one place in the water audit where we can input that. And for that master meter error adjustment, we would want to weight what that is, what those accuracy results are based on the percent of our supply volume. But that is the place in the audit where we would key in that master meter error adjustment. Right. All right, we got 2 more here. We'll run through. All right. Pin for the next question is 576-2400. All right. All right, here we go. All right, which of the following is not a component of authorized consumption? All right, good job. So leakage. So one common error that we see when folks are first picking up the water audit and using it is maybe they're estimating leakage in their system, which is a great practice. If you're doing that, continue to do it. But when it comes to the water audit, one common misstep we see is folks putting that leakage estimate in that unbilled and unmetered consumption category. And it's true that leakage, it's not metered and it's not billed, but we want to make sure that we leave any leakage estimates out because one, it's not an authorized consumption, and two, that's one of the volumes that we are exactly trying to calculate through the water balance and the water audit process. So leakage is the term that is not a component of authorized consumption. So good job there. All right, looks like Eagle has jumped into the lead there. Okay, let's go to our last question here. And our pin for this one, for the last question, is 1642613. 1642613. All right. Excellent. Okay, and here we go. All right, flushing and fire use are common types of this authorized consumption. All right, so most folks chose unbilled, unmetered, authorized consumption. All right, so real loss had a couple of selections there. Real loss would be is another name for the physical leaks in our system. And again, just as a reminder, it's not an authorized use. So this question is specific to that authorized consumption. There's 4 components to authorized consumption. It's that Will walked us through: billed metered, billed unmetered, unbilled metered, and unbilled unmetered. And so flushing and fire use are typical uses that we would find under unbilled, unmetered authorized consumption. All right. Excellent job, everyone. All right, so that's going to take us through our testing our knowledge there on the water balance. You guys did a great job, and just understanding those different terms are going to be really key to making sure that we're applying the M36 methodology when we're populating our water audit. I'm going to turn it back over to Will, who's going to run through or just an introduction to the water audit software and you're going to see a lot of familiar terms at this point. So Will, go ahead and take it away for us.
All right, thanks, Drew. So I'll do a flyover of the free water audit software with AWWA. This is the tool that you will be working with as we work together in developing your water audit and then working together to do the level 1 validation of that water audit. So let's get oriented to what's in that tool. I think most folks that are involved are not intimately familiar with the tool or fairly new. Some folks, I know a couple folks have been working with it before, and in some cases a while, but most folks are not. So I'm going to just give a flyover of how the tool's set up and how it connects to those water balance concepts that we just learned about: supply, consumption, how the consumption breaks down, billed, unbilled, metered, unmetered, the different types of loss. It's really just a matter of when we do a water audit, it is all about building a water balance and using that water balance to assess how the system is performing. But we can't build that water balance without those categories, and that's the underlying driver. Here's just a zoom out of water audits, and just so you know, this is not a local practice. It's actually not even a North American practice. The idea of a water balance was something that came about I would say formally came about 20 years ago, when the international community formed a task force. AWWA and American participation was involved in developing that. And this is really something that's across the world considered a best practice. Every year, developing water balance, you really need this to try to get your baseline understanding of how loss is behaving in your system. The version you're going to be working with is relatively hot off the press. This is a few months ago in a journal publication with AWWA that talked about the latest release, version 6, and some of those enhancements in that latest release. Just as a matter of interest, the history there is kind of cool. It's been about 15 years or 17 years since the very first version came out. And I mentioned about 20 years ago, the international community and American Water Works Association all said, hey, we all need to be using the same sheet of music here. We need a standardized way in which we're assessing loss that's happening every year, so we don't have 100 different people doing it 100 different ways, and we can get some standardization and some systematic approach to this, a rational approach to it. Well, that actually led to the realization that we needed a freely available industry standard format for conducting the water audit. So the very first version was in mid-2000s, and it was, let's call it very basic. I won't say it had a mouse and a wheel, but it was maybe just one notch above that. And it did some real basic comparisons. We had a whopping 200 downloads when it first went up on the website, AWWA's website. It was out for a few years, but 200, we thought that was pretty special at the time. That seemed like a lot. Fast forward, we're now at version 6, and there's a lot that's happened in between. One of the most important things was the introduction of the data grading matrix in version 4, and this was about 10 years ago. And that data grading matrix is really what introduces this notion of assessing the sources of data and determining what's better data and what's less, what's worse data, and recognizing that not all data is the same, and it's not all the same level of reliability. And so having some scoring system to tell if the results of an audit are more reliable or less reliable. And that was a big step forward, and also something that was a major enhancement on how that's done in the latest iteration of the tool. The trend in the downloads is a very clear picture of the adoption of this tool in the industry. So you are using the standard format, recognizing the industry as the gold standard for how to conduct an annualized water audit, use that to calculate performance indicators and to make decisions based on that. This is as developed and put out by AWWA. The latest version, it translated a lot of stuff and made it more clear, more easy to do, in particular assessing the data grades. And that's done so by answering a series of questions. That's a lot of the stuff we'll do kind of working together with our coaches and the tribal utility and IHS representatives. It also introduced a blank sheet so that you can do some of your math live in the tool rather than having to maintain separate files. That's a major benefit. And the latest version also has a new dashboard that features key performance indicators, that's acronym KPIs, that reflect what are the metrics that AWWA says you should be using. And we'll learn in there that percent water loss is no longer one of those metrics, but there are some others that we want to focus in. So let's go ahead and just do a flyover. Drew, I'll try to wrap this up in maybe 10 minutes or so we've got time for closing stuff for today's class. Because I know we're going to actually get into detail working with the live software. Everybody will get a chance. So this is your first look, your drive through, if you will. The worksheet is essentially a water balance flipped on its side. We work through supply at the top, owned sources, imported sources, exported. And we have an opportunity to apply an error adjustment if we have any known error in the supply measurement. We then move to the authorized consumption section. We have the categories we've discussed: billed and unbilled, metered and unmetered. You know, depending on how those answers shake out, we've got 4 options. And then we see, as I mentioned, for this category for unbilled, unmetered, there is an option for a default, or you can use a custom value. You can say, well, we track our flushing, so I want to use our tracked numbers. Or you can toggle and say, I don't track it, I need to use the default number, and it will supply a number for you. So that's a helpful, really just those 4 categories: parent losses of data handling error, customer metering inaccuracies, unauthorized consumption. We actually have defaults built in for the 2 hard ones, theft and data handling error. Those are pretty difficult to get our hands around. The tool has a default for folks that haven't really had an opportunity to investigate that. We don't have a default for metering under registration. We do have to supply a number there. If you don't have any data to go off of, you can make a guess or an estimation and document what your thoughts are and the basis for that estimation, and then work to improve that over time. But in the beginning, especially if this is your first water audit, one of their key messages is it's okay to do estimations. That's important to get you started, and those estimations can be improved over time. And eventually maybe we can get to more measured or quantified and validated values over time. Down at the bottom of the worksheet, we have the last 2 sections are system data and cost data. Some basic system parameters, length of mains, how many service connections we have, and then the average pressure across the system. Those are the 3 key ones. And then the retail units that we charge our customers on average per unit of water, if it's 1,000 gallons or 100 cubic feet, depending on how you bill. And then this final one, which is variable production cost. We'll give you some guidance on how to calculate that, but it really factors in your purchase water, your chemicals, and your pumping costs. And you just add up some of those costs and divide by what you produce. So fairly accessible, and a lot of the data, really most of the data you need to populate this worksheet is stuff you're already tracking. There may be something you have to go and track down, but for the most part, a lot of these entries end up being things that are already maybe on your monthly reports or other places that you're tracking. Down at the bottom, there is some guidance on the worksheet. If we want to improve our data validity, it gives us some recommendations on what categories to work on first. And that can be very important to make this tool not only an assessment of how we're doing now, but also a planning tool for what we should be doing next. And that's a theme, a philosophy that you'll hear over and over in working together with us, which is you need to know how you are and how you've been, but you need to use that to then make plans for where you want to go, what you want to do. I'll go ahead and hit the blank sheet. Again, a spot to do some math. Here's a good example of somebody had taken some test reports from some of their field activities and just pasted in the images in there just because they wanted to have them in there for reference. And then when they were summing their boundary meter volumes and their customer consumption, they put it in there, and then maybe made, it's Excel, so you can use it to make charts and visualize some things. In this case, that helped to identify oh, well, we had negative water loss one month. We had sales that were greater than the amount supplied. You know, scratch your head, what's going on there? You know, so visualization can be helpful in doing that. So the blank sheet gives you a spot to do that. The dashboard is the feature is sort of the output, the results of the audit after you've done the input. And it has a couple components in there. I'll highlight those at a very high level. The data validity is always the first thing we look at. It's on a score from 1 to 100. And in this particular case, the score comes in at a 57. What we really want to take away from that is that it falls into tier 3 out of 5 tiers. And so we're in that 3rd tier, and the loss control planning information that's built into the tool tells us that because we're in the 3rd tier, we can be thinking about next steps in these terms relative to different focus areas. What do we need to be thinking about in terms of our data collection? What about short-term loss control? What about this year's budget? And, you know, should I be thinking about doing some leak detection or maybe replacing some meters? Well, the fact that I'm in tier 3, it gives me some general guidance on, okay, is my data validity good enough to start planning those type of activities? You can see if I'm at a certain low level of data validity, it's way too soon to do things like set targets or compare myself against others in benchmarking. So this is all sort of built in. I'm hitting it at a high level now. We will dive into it a bit deeper as we work together, looking at your data, looking at your audit, looking at your data validity score, your tier, and that type of stuff. But just know this is oriented to give you guidance on how to move forward. This is the dashboard that compares volumes and values side by side for non-revenue water components. We talked about that concept when we defined non-revenue water a few minutes ago. But this becomes really helpful to me when we're thinking about what our priorities should be. So my most expensive issue, if this is my system, is real loss. That's the biggest cost impact, and it's also the biggest volume impact. So if I'm prioritizing my work, assuming I feel good about data validity, and we're at least confident enough in the audit results, then I'm probably going to prioritize some type of leakage management activity, be it acoustic leak detection, maybe setting up district metered areas, or deploying loggers. You know, it could be a number of different activities, but I know that that's the category I probably should focus on. And then I might not ignore this one here because it does have a next largest cost for customer metering inaccuracies. So that's the type of approach we'll be working together with you when we're helping you to interpret the results from the water audit. Finally is the dashboard. We affectionately call this the fighter jet dashboard. It just makes ourselves feel cooler, like you're sitting in the cockpit looking at all these metrics. One of the takeaways from a research project from AWWA was the conclusion that there's not a single number, a single metric that really truly tells the story of how your system is performing with respect to water loss. You might have a high volume indicator, that's the blue ones, but you also may have a low cost indicator. And that could be, well, our leakage is high, but we have a very, very cheap source. And so the cost of that leakage is not exorbitant. And so if it costs us $1.50 to recover, but it's only $1 that we recover, now we're investing more and to get back what we're trying to get back. So, you know, we're over investing essentially. So these metrics need to be kind of looked at as a whole. And for some systems, they'll dial in on, for example, gallons per connection per day, and they'll track that over the course of time, multiple years. And they'll say that's the measure that we're really focusing in on. In other cases, it's helpful to look at the cost indicators. All of that we'll be there with you to interpret what your fighter jet dashboard is showing. What does it mean, and how does that inform your next steps? The other and final piece that I'll mention on these speedometer type dials, these gauge charts, is that the low to high range is built upon data from North America of validated water audits that have been collected at different places in North America that are showing kind of what the typical range for these measures is in North America. So when you're audit shows you your dial and your measured value is at 39 gallons per connection per day. If that's your result, then that tells you that you're just slightly above the median for typical ranges in North America. It just gives you a bit of context of, okay, where does that say we are relative to the overall? It doesn't tell you where you should be, so it's not your target, it's not your goal, but it tells you where you are and where you are relative to others. If you do have a target that you've set, you can actually key that in and it'll show up in a dashed blue line, and that gives you the ability to visualize tracking from where we are now to where we're trying to get to, and how far do we have to go. So that's a built-in feature there. Drew, I'll punt back to you and ask you to pick up from here. And I'm not sure if we're doing another Kahoot or if this is our wrap point on the session. I'll defer to you on that, where you want to go.
Perfect, Will. Thank you. Actually, we're gonna go to our wrap portion of the day here. We've got about
Great.
10 minutes left in our session. Thanks so much for that flyover of the water audit, Will. For those on the line, don't worry, we're going to get hands-on on the water audit tomorrow. So we'll, you've heard us talk about it a lot today. We're going to bring up a live version of it and just kind of give you a tutorial and get you familiar with some of the bells and whistles in it. Then we'll actually start working on putting some inputs and populating the water audit tomorrow. So this was meant just to be the first of several introductions into this industry standard tool. You got some good comments on the water audit too, and it has, for those of you who have used previous versions in the past, will certainly appreciate the improvements and enhancements that have been put into the current version that we're going to be working with in this program. All right, so what we'll do now, what we have left here in just these last few minutes, is to do a quick summary and review, and then also we want to make sure that we do our daily evaluation of the workshop. So let me get my slide running here. Okay. Okay, great. So just a summary of some of the information we've covered today, guys. Starting in the middle, and something that we always start with is that big picture approach of showing the progression of a water loss program, and really just trying to capture the essence of the M36 methodology here in that big picture approach. It all starts with the water audit. So that's really the key focus of this workshop and this program. So establishing that rhythm and that baseline of water auditing data using the water audit on an annual basis. Only through using that tool annually can we really start to appreciate our water loss and non-revenue water trends over the years, and separate those water losses into apparent losses and real losses there. Will showed us in one of the snapshots here at the bottom of the screen, shows us that non-revenue water profile and some of the ways that we are looking at the results of the water audit, the volume of water that we're losing each year, how much it's costing us each year, and then how valid the data is, how reliable we are in the data that we're putting into the water audit. We walked through the water balance in detail. So moving from left to right, understanding this mass balance approach, that we are through this systematically accounting for all volumes of water going into our distribution system. So that's done through metering, and some of these volumes of water are more appropriately estimated. So think about those that are unbilled and unmetered, or maybe billed but unmetered. They need to be estimated in some way. But the key takeaway through the water balance is that we are accounting for all volumes of water going into our distribution system. Water supplied, that's the most important volume that's going into our water audit. It sets the stage for that water balance at our starting point. So that's why we had that exercise where we talked through our system setup, and each of you had a chance to work with your coach in drafting that water audit boundary in our breakout exercises, understanding where those meters are, also acknowledging that we don't always have that meter that's capturing those treated sources entering our distribution system, and in some cases we need to use those raw water meters to get our best volume to go into the water audit. And also just the acknowledgement that we're not looking at our water loss as a percentage. One big change that Will mentioned in the newest version of the water audit is there's no percentage-based metric in that in the results tab, in that dashboard tab. So we're not looking at water loss as a percentage. We are instead looking at it in terms of volume and value. So you're going to hear us say that. You've heard us say that many times today. You're going to hear us say that many times throughout the course of this the rest of the workshop as the industry standard way of looking at our water audit results. Tomorrow we're going to we'll kick off with a little bit of a refresher, and then we'll go into the water audit software, bringing up that live version and walking through a demonstration of the water audit software, and then we'll talk about how to approach developing the inputs when we're ready to start keying in some of those things. What considerations we need to make before we start punching numbers into the water audit, and then we'll have some breakout common exercises, and then introduce that concept of data validity. So it's been a full first day. Hope you guys have enjoyed it. What I'm going to do now is I'm going to share our daily evaluation. So please stay on the line for us to pop that into the chat, and we do greatly appreciate your feedback. This helps us continue to prepare the best possible experience and workshop for you guys. So it's another just easy Survey Monkey link that I just popped into the chat feature here. It tells me that it should take about 5 minutes to complete. We're going to remain on the line. If you guys have any questions or any issues accessing that, but I'll just give a thanks in advance for completing that, and look forward to seeing you guys in the workshop tomorrow. And just to make sure that nobody runs away, in just a few minutes, I'm going to post the results from the Kahoot questions. So you'll want to stay tuned for that.
Is there a Olympic ceremony with the gold and the silver and the bronze, Drew?
Well, we're just going to have everybody's just going to have to wait and see, I think.
Teaser, appropriate teaser.
That's right.
Folks are okay after they do the closing eval. They're okay to go after that.
Yes. Yeah. That'll be a good adjourn time.
Sounds good. Thank you. Thank you for the day today, Drew. I enjoyed it, and looking forward to seeing everybody tomorrow.
Excellent.
You're great. Thank you, Hank.
For those few folks on the line that have not yet received their manual, I'll track down the tracking codes and see if and then get back to you guys individually as to when you can expect to receive that. Should be coming soon.
Thanks, Drew.
You bet.
I'm hoping it shows up today.
The copies of the presentation will be available. We're going to post those to our website. We did send some PDF versions out in advance, so it may be check and see if that landed in spam. But we're going to post those to the program website as well at ihswaterloss.org. Yeah, the video, we did record this session today, guys, so we're going to make that available to everyone as well. We're going to continue to do that throughout the week.